Hey guys, welcome back to my channel. In today's video, we are going to see how to find second largest element in an array, right? So before going into this video, I would recommend to watch this video to find the largest element in an array, right? So this is a prerequisite. So you have to know this concept before watching this video, right? So if you haven't watched, please check the I button, watch the video, and then come back to this video. So let's say, um, let's directly jump into the intuition, like how to solve this. So I've said that you should be knowing this. So let's say, like, how we found out the largest element. See, basically what we did, let's say L, I'm going to store the largest element here. First of all, I took some negative value, some infinity negative value. Of course we can't store infinity, so we took basically int min, basically the minimum value possible. And then we are going to iterate through the array, and we are checking if the element is basically greater than the largest or not. If we found that new largest element, we are going to update. We are going to say, let's remove this and place 8 here. And then I'm going to check for further indices. So the pointer will come here. I will check for 1. 1 is the greatest. Is 1 larger than the largest element? No, right? So let's not change anything. Move forward. 2. 2 is of course lesser than the largest element. I mean, till now the largest element is 8 only. And then here comes the 9. Oh, 9 is greater than the largest element. That means we have got a new largest element. So change this and let's say that, bro, you are not the largest element anymore. Let's give this position to 9. So 9 is the largest element now. Next index 10. So 10 is the largest element now. So remove this 9, place 10 here. And here see 0. 0 is lesser than 10. So don't change anything. So at last the largest element is 10. So using this same intuition, can I find the second largest element? Can I do that? Can I think something like, see, the moment I'm getting a new largest element, I'm going to store the old largest element in the second largest element, right? So let's say, instead of keeping track of only L, I'm keeping track of largest element and then second largest element also. And then I'm going to iterate. So let's start iterating. See, the pointer will be here at first. Okay, so first of all, I'm just going to initialize this with minus infinity, or let's say, int min or something. And then I'm going to iterate, right? So first of all, 8 came. Okay, 8 is greater than this minus infinity. So I will change this. So 8 will come here. But before before placing 8 here, I have to place this largest in second largest. That is minus infinity for now. And then I'm placing the new largest element in this largest, right? So 8 will come here. Okay, I'm moving forward. 1 is greater than 8. No, that's not the new largest element. Okay, 2 2 is not the new largest element because see, 2 is lesser than 8. Okay, 9 comes. Okay, so 9 is greater than the largest element I have. So 9 is the new largest element. So what I'm going to do, I'm saying, bro, this largest element, no, the older one. I'm going to say, bro, you are the second largest element. You are not the first largest element anymore because right now I got a new first largest element, right? So bro, please move to the second largest element. So 8 will come here. I'm going to put this new largest element here. So 9 will come here. Again moving forward, 10 comes. Oh, again one new member came. And I'm saying, bro, 9, please move to the second largest element because I've got a new number as the largest element. So I'm going to place 10 here. Before that, I'm going to move this to the second largest element. I'm going to place this 10 as the largest element. and then I'm going to move forward. 0 comes, of course 0 is not the new largest element, so let's ignore this, right? So see, right now I've got this largest element as 10, second largest element as 9. So this algorithm is working perfectly, and I'm asking you, will this work for all the test cases? Will this work for all type of arrays? You might be thinking, of course it will work, right? I mean, the moment we get a largest element, we are going to store the old largest element in the second largest element, and we will update the largest element also. So ultimately, we are getting the largest and the second largest, because the moment we are changing the largest element, we will update the second largest element. And what if I'm saying, what if there is a second largest element, and to find that, we are not changing that largest element. Uh, what I'm trying to say is, let's say there is an example, something like, let's say the same example I'm taking, but I'm making some changes. Let's say 8, 1, 2, 10, 9, 0, right? So this is the new array, and I'm going to do the same operation here. So what was that operation? Largest element, okay. Largest element, second largest element. First of all, minus infinity, minus infinity. Okay, I've got one new one. So bro, please sit here, and I'm going to place 8 here, right? So 1 comes, okay, 1 is not the new largest element. Then I'm going to 2. 2 is not the new largest element. Then I'm going to 10. Okay, 10 is the largest element, right? So please bro, move to the second largest element. Let 10 sit here. So 10 is sitting here. And the second largest element right now is 8, which is true. But the moment I comes here, here 9 is there. 9 is the new largest element? No, because see, 10 is already present. It is not the new largest element. So we won't make any changes, right? We will move forward. 0, 0 is the largest element, I mean new largest element? No, right? So we won't make any changes. So see, here the largest element is 10 and the second largest element is 8, right? Okay, largest element is right, but second largest element, bro, this is not 8, this is actually 9, right? So see, we were updating second largest element only when there were some bigger numbers. So at that time, we used to keep this largest element in the second largest element, and we used to keep the new largest element in the largest element, right? But what if there is an element, let's say E, there is an element E that comes in between largest and second largest, right? So we have to check for this condition also. We have to check for this condition also. So while checking for the largest element, we will go and check for this condition also. If the element comes between second largest and largest, that means, bro, second largest, you are not the second largest anymore, because see, E is greater than you. That means E is the second largest, right? So see, here 9 comes between 8 and 10. So 9 will become the second largest element. And largest element, we are not going to change it. In this case, right? In this case, largest element is L only, but we will only update second largest element, right? So the pseudocode, this will look something like, we are going to iterate from int I equals to 0, I is lesser than n, I plus plus. And here I'm going to check, bro, is there any new largest element? So if the current element, is greater, let's initialize this greater with, let's say, minus infinity, but in program, of course, int min, and second largest, let's say int min this also, and the moment And the moment we got a new greater element, I'm going to place this greater element into the second largest element. So S will be G. Okay, like we were using L, right? So let's not use G here. Let's use L only here. Like, this doesn't matter, but I'm just using the same variables. You won't get confused. So L, okay. Basically, I'm placing this largest element in the second largest element, and I am updating the largest element with this ARR of I, right? Okay, so this condition is done. This condition is done. But there is some more condition. There is some other condition that what if ARR of I is greater than second and ARR of I is lesser than largest element. See, in this condition, the element is lesser than the largest element. So largest element will not change, but the second largest element will change, right? So in this case, S will be equals to, that means the second largest element will be equals to this current element. And that's it. We are going to close this for loop. Okay, closing this for loop. So at the end, if second largest element is still int min, that means we didn't get any second largest element. But if it is not, if there is some value, if it is not equals to minus infinity, that means there is some value. So that is the answer. Okay, so now let's code the same thing, right? So ARR is the array and n is the size, right? So let's declare those two variables, right? Basically the largest and second largest. So largest uh, will be int min at the beginning, and second, let's say second is basically second largest. So int min, and I'm going to iterate through this I n I plus plus. Here I'm basically going to check if the current value is greater than largest or not. If it is, first of all I will say, bro, largest, please move to the second largest. So I will just place the largest uh, in second largest, and then I'm updating this largest with the new element. Okay, so this condition is fine, but I have to check for some other condition also, which was that what if the element is second largest and it comes in between largest and current second largest, right? So if the element is lesser than largest, that I agree, okay, it's lesser than largest, but bro, this element is greater than second, basically second largest. In that case, I'm going to modify this, sorry, second, and I'm going to place this new element. I'm going to say, bro, second, please move. I've got a new second largest. So I'm just going to print. Okay, before printing, I'm going to check whether the second largest is equals to int min or not. If it is int min, that means we didn't get any second largest. I'm going to just say, bro, not found, not found. Else that means in second there is some value. I'm going to print that value, right? I'm going to print that value. So let's run this and see. Okay, 3 2 3 1 0. Okay, 3 is the largest element. Okay, let's add one more, maybe 10. So in this time it should be 9, right? So the size is increasing by 1. Okay, size is 7. Let's run this. See, the second largest is 9. Now let's say, like, if there is no second largest, let's say everything is 1, right? How many are there? 1 2 3 4 5. So 5, and the size is 5. Basically we didn't get any second largest, so it should print not found. Okay, not found. So it's working. So that's it for the video. If you like the video, hit the like button, subscribe to the channel. If you have something to say, please comment them down. Until next time, see ya.